Now we will explore one of the most practical applications of Vedic mathematical wisdom, right? Calculation methods that enable rapid mental computation through pattern recognition and algebraic shortcuts. And later I'll talk about how artificial intelligence, what we are doing, is kind of connected to this, right? We're talking about calculation methods that enable rapid mental computation through pattern recognition. You look at numbers, we recognize patterns, right? Uh, and the algebraic shortcuts. The Bhagavatam and related Vedic texts describe sophisticated calculation methods that demonstrate mathematical understanding far ahead of their times. These aren't just computational tricks, they are systematic approaches to mathematical problem solving based on deep pattern recognition. Let us show you three fundamental techniques. Right? Ekadiksha Purvaina, by one more than the previous. Ekadikshana Purvena. This technique uses pattern recognition to solve complex calculations through simple mental operations. Nikhilam Navatashakritam Dashta, all from 9 and last from 10. All from 9 and last from 10. This method transforms difficult calculations into simple subtraction operations. The third one, Uddhava Triyabhigyam, vertically and crosswise. And we'll just see this in example below, right? This technique enables rapid multiplication through systematic cross multiplication patterns. Okay. So let's look at the calculation here on the left side, where we'll demonstrate, right, Uddhava Triyabhagyam with example of multiplication 97 times 96. What's step one? You take 7 times 6, that's 42. And then you say the last digit in 42 is 2, and the carry is 4. Right? So in your answer, the last digit is 2 and the carry is 4. In step 2, you do cross multiplication. So 9 times 6 plus 9 times 7, right? And then you add that, the 4, which is carryover from step 1. Okay, all of this you do mentally, okay? The total is 121. In 121, the same thing, the last digit is what? 1. And what is the carry? Everything before the last digit is 12, right? And what is step 3? You multiply straight 9 times 9, right? 81, and you add 12, which is 93, right? So, answer is what? 9312, 9,312. Is that the step 3, what you get, result, right? And then we already talked about the 12 carry. So that's 9312. Okay, amazing. The more you do this, follow these steps, you will see what I'm referring here, right? You can solve large multiplications mentally, yes, without using calculators or anything. And the beauty of this is the more you do it, and that's the beauty of, we'll connect again with artificial intelligence, is you're training your mind, you're activating connections in your mind, right? The more you do it, the more sharper the connections, the visual connections happen. So these can be done entirely in your head in seconds. Right? Now let's look at the modern calculation here, right? So modern mathematics has rediscovered and formalized many Vedic calculation techniques, Vedic calculation techniques, now applied in computer algorithms, digital signal processing, and educational methods. The Kartsuba algorithm for fast multiplication follows the same logical pattern as Uddhava Tribhagya, right? Fourier transforms for efficient computation use similar pattern recognition principles. Pay attention to that, right? The Trachtenberg speed system for mental math is essentially a rediscovery of ancient Vedic techniques. Same thing, now you look on the right side based on the algorithms. Your step one, you're assigning, individual numbers to A, B, C, D. Then you do, cross A, C, B, D, right? And then you could do the step one, step two, step three, step four, and eventually you get the same result 9312, 9312. So in the computer systems, you're using this is the way you use to get you the answer. Okay. Same result, but ancient method is actually more elegant for mental calculations, and it also enhances our mental abilities. So the comparison reveals fascinating insights. What are those? Speed. Vedic methods are optimized for mental calculations, while modern algorithms are optimized for computer processing. Application. Ancient methods excel in educational and mental math, while modern versions are used in digital signal processing and cryptography. The remarkable truth is that ancient Vedic calculation methods often outperform modern techniques for human mental computations, while modern algorithms excel in computer applications. This suggests that ancient mathematicians understood human cognitive patterns in a way that modern education is only beginning to rediscover. Why do we say that? That's what a lot of our what we call artificial intelligence algorithms are based, LLMs. Right? Moving on, let's look at different practical applications. Right now, let's explore how the mathematical principle described in Bhagavatam had numerous practical applications in ancient civilization and continue to influence modern technology and education. Right? The mathematical principles described in the Bhagavatam weren't just theoretical. They had numerous practical applications in ancient Indian civilization that demonstrate sophisticated understanding of applied mathematics. Astronomy, precise astronomical calculations for calendars enabled accurate prediction of celestial events, seasonal changes, and religious observances. The mathematical precision required for these calculations demonstrates advanced understanding of trigonometry, geometry, and time measurement. Let's look at it from architecture perspective. Temple architecture using sacred geometry created structures that were not only aesthetically beautiful but also acoustically and structurally sophisticated. Right? Today, if you go to India, you will find some of this ancient architecture and you will be amazed at that. The mathematical principles governing these proportions continue to influence modern architectural designs. So, good commerce. Navigation and maritime trade calculations enabled ancient Indian merchants to conduct trade across vast distances with mathematical precision. These calculations required understanding of geometry, trigonometry, and complex numerical systems. These weren't primitive applications. They required sophisticated mathematical understanding that rival modern techniques. The mathematical principles from the Bhagavatam find numerous applications in modern technology, education, and computational systems, often in ways that directly parallel ancient applications. Let's look at computing. Digital signal processing algorithms use mathematical principles that parallel ancient Vedic calculation methods. The efficiency and elegance of these algorithms often mirror the pattern recognition techniques described in ancient text. Education. Mental math and speed calculation methods based in Vedic techniques are increasingly adopted in educational systems worldwide. Students using these methods often outperform those using conventional approaches. Security, cybersecurity. Cryptographic algorithms and data protection systems use mathematical principles that can be traced back to ancient understanding of numerical patterns and relationships. The parallels are striking. Ancient astronomy, modern computing. Ancient architecture, modern education. Ancient commerce, modern security. The transmission path shows how ancient knowledge continues to inform modern applications, ancient knowledge transfer into modern applications. This isn't just historical curiosity, it's evidence that ancient mathematical wisdom contains insights that remain relevant and valuable for contemporary challenges. The mathematical principles preserved in Bhagavatam continue to provide innovative solutions for modern problems in ways that purely contemporary approaches often cannot achieve. The integration of ancient wisdom with modern technology represents one of the most promising frontiers for mathematical and technological advances. In the current time, modern times, is more parallel as artificial intelligence is picking up and the algorithms and what mathematical calculations they are using across the world.